Hey, it's Kevin Lawton with the New Warehouse Podcast here at MODEX 2022. I am in the booth joined by Blair of Berkshire Grey. Pete has been on the show previously, way back ProMat 2019, I think, when I was running around with a handheld recorder. So it's good to be sitting down this time and talking and catching up with you. So if people are not familiar with Berkshire Grey, why don't you just give us a brief overview of what you guys do?
Sure. So first off, Kevin, thanks for having me.
Yeah.
So Berkshire Grey, we do robotic automation for supply chain and warehouse applications, everything from e-commerce fulfillment to store replenishment to back of store and micro fulfillment. Basically taking AI, robotics, and other technologies and combining them into really innovative solutions to help people solve that labor challenge that everybody's faced with.
Yeah, that's the big discussion point here, I think, and for operations all around, people are struggling to find labor and solve that issue. So many people here obviously trying to solve that issue, and I'm sure you guys are as well, right? So talk to us a little bit about how you're kind of working to solve that and some of the solutions you're bringing to the market.
Sure. So what we do is we work with customers, and we're looking at their most labor-intensive operations and processes. So typically those have things to do like break pack picking for store replenishment, e-commerce fulfillment, sortation of orders, and those kinds of things. So we do other things as well. We do mobile robotic sortation. We basically can turn any floor into a very flexible unit sorter, able to handle things that you wouldn't put on a tilt tray sorter. Actually, we were demoing in the booth all week, handling flats of jars of tomato sauce, right? I mean, people say, like, why are you doing that? It's like, well, you can put that on a tilt tray sorter, but you probably wouldn't want to. So it's an innovative solution. It's a different application of mobile robotics to bring basically anything in randomly, cases, items, even containers. We are able to buffer store them kind of on the floor and then sequence them out in a very ordered manner, in a strategic manner, if you will. So that could be to build pallets in a certain way. It could be to load delivery vans in a certain route order that changes like every day with every route. Or even to do things like store aisle friendly put away at stores. So basically load the trucks with pallets ready to go, pull right off the truck and go directly to a specific aisle out in the store, and do that on a very regular basis. Doing it all with automation. There are other people who've tried this with conveyor and other things, and if you have certain products, it would work. This is able to do it with lots of different things.
Right, so I think that variation and the flexibility is certainly a key in facing some of the challenges we have today, right? So being able to do that, and obviously, as you said, set it up and tee yourself up so that, when it gets to the point of delivery, it needs to be unloaded and it can really just be easily put away in the sequence that it needs to, which is a huge cost savings, huge time savings as well, right? So now you have some other solutions too that you guys are showing off here. You guys have a big setup, definitely, rightfully so. I think you guys, even back at ProMat 2019, you had a fairly big setup too. So talk to us a little bit about some of the other stuff that's in the booth as well.
Sure. So one of the things that we debuted at this show, though we announced it last quarter, but the first time we showed it publicly, is an automated put wall. So this is the idea of basically, people are familiar with put walls for things like e-commerce fulfillment, right? You go batch pick a bunch of items into a tote or into a container for a whole bunch of orders, take them to a manual put wall where a person sort of scans things and walks around looking for the light, drops them in. Those systems, see the light. Those systems, a person can effectively work about 80 of those cubbies, right? And then after that, they're walking around too much and they get confused, they get inaccurate and less efficient. So what we've done is we've automated that sortation process whereby a single operator standing in a station where they don't leave just takes items, scans them, and places them into the machine. And then inside of basically shelves that kind of look like normal shelves, it's sorting. There's a track inside that's sorting those items out to the individual orders. And that person is actually able to sort up to about 240 orders at the same time. So one operator is doing equivalent, with customers who are using it today, about an equivalent of what 3 people would do with manual put wall situations. So, and so it's advanced automation, right? So there's robotics in there. There's certainly a whole software layer as well, and it's a step, right? One of the things that's about this system that we purposely engineered for was a number of things. One is to fit into the processes that people already run, right? So if you have manual put walls, you replace those with this, and you're immediately more efficient. And your rest of your operation can run the way it did. So pack out could be the way it was run. Your batch picking upstream can be the way it was done. And one of the nice additional benefits, besides that person being 3 times more efficient, is you can actually gain some efficiencies in the picking process. Even though we're not automating that, by allowing the people who are doing the batch picking to pick bigger batches, they're more efficient, up to 25 or 30% more efficient in the picking process. Again, not adding automation, but just doing bigger batches that come to the sort wall, because that sort wall can do more with the one person who's there. So had a lot of interest in that, a lot of uptake. And we've architected it, engineered it really for the kind of environments these go into, right? It needs to be rock solid. We don't have a lot of moving parts. It's very fast. It's industrial. It's built. You don't need. We had a kind of a mantra, which was sort of like zero maintenance required. Nothing zero maintenance, but if you can minimize it, if that's your goal, you sort of. You engineer differently, and that was a primary thing because of the environments these are going into, right? They're going into places that are distribution centers, and we all love working in distribution centers, but these are not penthouse apartments.
That's true. I mean, I think that's a really interesting point there, because the other thing is, if you're relying on these automated put walls as well, and different robotics and things, if that's what's really driving that productivity, and something goes down, and you need to do maintenance or something, and you stop the operation. Now you got to figure out this workaround and everything, and you get all over the place. So it's great that you guys are thinking about engineering in that way, that it should be virtually maintenance free. We'll say 0.01% maintenance free, something like that.
Go with that. That's
we're down. Zero maintenance, but obviously things happen. So it's very interesting to see how you guys have developed all these different things, and been able to bring them to the market and address a lot of these challenges that people are seeing. And I think there's one more thing too, right, that you want to talk about?
So the other thing that we debuted at the show, and we literally just announced it, we've been piloting it at a number of customers recently over the last 6 months or so, is autonomous robotic picking, identification, orientation, and packing directly to an auto-bagger machine. So it's our robotic system with vision and software and all the intelligence required to basically look into a bin of things, pick them out, identify them, and the identification does a couple things. One is we're now able to pass that message up to the cloud and back down to the auto-bagger, so that once we orient the item. So people always say, why are you orienting? What does that mean? Why don't you just pick it and drop it? Well, if you think about different items, a bag is opened a certain way, and we were demonstrating some things that were sort of longer, on one axis, right? And if the robot doesn't know how it picked it up, it just picked it up. If you just moved it over and dropped it, some percentage of the time it's going to bounce out or cross over the bag, rip the bag, those kinds of things.
Fit right in the opening,
Right, so in real time, as we're identifying the barcode that's on the item, so we can pass that over to the auto-bagger so they can create a customer label, we're also figuring out how that's oriented so that we can manipulate it and drop it into the bag correctly.
Got it.
So it's something that's like long on one axis, we make sure we turn it, spin it, tilt it, however, to get it in there. And then we're working with different auto bagging vendors, right? And some of them have a flat opening, some of them have a tilted opening, some of them have it's an orientation to the side or to the front. And so being able to handle all those different kinds of orientations as well as put mechanisms requires being able to manipulate the items that way. And so that technology is part of our core robotic manipulation technology for picking across different types of applications, everything from picking. So that's putting it to auto baggers. We use that same technology to do things like brake pack picking for store replenishment into totes, reusable containers, and those kinds of things. And then we've built additional solutions around these sort of core fundamental things that we do.
I think it's very interesting because you're adding that layer to the robot itself, because very often the robot is very black and white. It's like I pick up something, I put it here. I pick up something, I put it here. But now you're taking that robot and having it think another layer of like I pick up something, but I need to put it here, but I need to put it here in this way.
In an intelligent manner, right? You see it actually. We've seen it on the floor and things that. Look, there's a lot of robotics companies that can pick something up, move it 6 inches, and drop it, and do that really, really fast. And one of the things I always challenge people on that is like, well, where are you doing that in a warehouse? Right? If you've been in a warehouse where you need to pick something up, move it 6 inches, and drop it, I don't know if maybe that application exists, but we just don't see it.
Right.
So, basically it's taking robotics and doing something intelligent with it. So, to put things into an auto bagger, to pick, identify, place things into all kinds of different containers, handle different kinds of packaging, all those kinds of things. It requires another level of intelligence, and that's really kind of the core foundation of where we came from on the picking side.
Yeah, it's a very smart approach to go about it, and I think you have a great point there. Of you can move something a little bit of space, but there's a lot more variability to things in the warehouse, and you need to be able to have that robot think in that way, kind of at the next level, and be able to make some type of decision and make some kind of maneuver to get things exactly the way they need to be, or else we don't have that flexibility that we love to have in the material handling industry, right? So very interesting stuff talking to you here, Pete. Berkshire Grey, is great to connect again. If people want to find out more information about Berkshire Grey, how can they do that?
Sure, straight up as everybody else, hit our website, right? So www. Did I do that 3 times? www.berkshiregray with an E.com. So gray with an E.com. So www.berkshiregrey.com.
All right, great. And we'll put all that information at thenewarehouse.com as well. So Pete, thank you for coming by the booth and talking to us here on the show.
Thanks for having us on.